So now we've learned a bit about the basic mechanics of dictionaries, and now we're going to solve a problem. And the problem we're going to solve is, let's assume that you are going to see a bunch of words and you want to know the most common word. This is another word for this is the histogram problem. It's like how many of these things, and these things, and we're going to use a dictionary for it eventually. But before we do that, I want you to run through a little exercise, and I'm going to show you a number of names, and I want you to keep track of which one is the most common and how many times did you see the name. But I'm only going to show them to you one at a time. And so the purpose of this exercise is less about you knowing what the number is and more about trying to watch your brain and figure out how your brain struggles with this problem. And then we'll show you how Python might struggle with this problem and how we solve this problem in Python. So we ready? So I'm going to show them to you one at a time, and grab a piece of paper, do whatever you want. Ready? How you doing? So that was the last name. What was the most common name and how often did it occur? Maybe you have to go scroll back. Go back and forth, scroll back and forth. This turns out to be a problem that humans are really not very good at, especially if I was going to give you 1,000,000 words instead of just, 16 or 12 or whatever I gave you. If the screen I'm going to show you next, you'll see like humans are good at this, except humans are good when they can see all the data. Humans are not good when they only see one little bit of the data at a time. So now your brain goes like, oh, what am I doing? Let's see, how many? Marquard, that's only 3. Gen looks like, oh, Gen's a lot. Gen is 1, 2, 3, 4, 5. And has anybody got more than Gen? Chen is like, so Gen, 4, yay. Oh, no, actually Gen 5. That's another problem we humans have. We will miss one. We are pretty good. So the way our brain, it looked around, my eyes were going this way and this way and this way, and then I make a hypothesis and test the hypothesis. That's not how computers think. They don't like that. They're not dynamic like we are. Even though sometimes we write programs that make them seem dynamic, that's not how they work. So if you had to really solve this program, you probably, if you were smart, would have made a little piece of paper. And you would have drawn a little picture like this. And you would have done, each time you would look at the name, you would check to see if it was a name that you already saw. And if it was a name you already saw, you'd add 1 to that name. And you're like, okay, there's one more of those. And there's one of those. And now I got another one of those. And now I got one of those and 2 of those and whatever. And, or here's a new one here. And I got one of those. And on and on and on. Just tick these things off as you move through. And then when you're all done, now you go look at these numbers, 5, 7, 6, 5, 1, and you're like, okay, that's the one that I want. And so this is a little set of counters, and you can think of this as a histogram. It's like a little histogram of that's growing, and each time you see one, you add a little bit more, and you add a little bit more, and you add a little more, add a new one, grow that one, grow this one, grow this one, grow this one, and then you're all done. You got sort of the tallest histogram. You could think of these numbers as growing histograms with the names here on the horizontal axis. That would be a way to mentally think about this problem for a human to think about the problem. And so we're going to use dictionaries, and we are going to, in those dictionaries, we are going to make the keys be these things, the actual strings, these names, and then the values will be the current count. And then we're going to update those counts. So that's the data structure that we're going to build in Python. And it's really common for histograms or any other word counting, various other things, any kind of frequency. So what we're going to do is we're going to take these names, CSEV or Chen Wen, and we're going to use those as the keys, and we're going to use strings as our keys in our dictionary. So we start with our dictionary. And the first one we see is CSEV, so we haven't seen them yet. And so we put, we'll put 1 into there under CSEV, under the tag CSEV. We see Chen for the first time, so we put 1 in there for her. And then we print. It's like this is our current histogram as we've got it so far. CSEV has 1, Chen has 1. CSEV has 1, Chen has 1. But we're not done yet. Now we see Chen again, and we go grab, well, what was the previous number we had for Chen? Well, it was 1. Add 1 to that, so that's kind of like ticking this, and then stick it back in, so that's storing it in. So now we have this dictionary that's kind of growing as time is progressing. So Chen has 2, Chuck has 1, and away we go. So you get the idea that if we use the names of these people from our input data as the keys in the dictionaries and the values are the counts, then we can easily make a histogram that we can expand every time we see a new name and update the old ones, update the new ones, add a new one, etc., 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 that this works in a very nice and dynamic way. Now, it wouldn't be Python if we didn't talk about the kinds of things that you can do that cause tracebacks. You can't, if this is an empty dictionary, you can't go grabbing a key that doesn't exist. I wish Python did this differently, but it's not how it works. Python basically does not allow you to look at a key that doesn't exist. Actually, a list works the same thing. If there's 4 things in a list and you look at sub 10, the list blows up 2. We saw this with strings. If you look for a character beyond the end of the string, strings are unhappy as well. So Python is unhappy when you go and look for a key that doesn't exist. But like in all situations in Python, there is a workaround, right? It's telling us key error CSIV. But there's an in operator. We used it for strings, now we've used it for lists, and now we're using it in dictionaries. And it asks not the value, it's saying, is this key CSIV in this dictionary CCCC? And in this case, because we just created this dictionary, we're doing the question, it's false. So now we can write an if statement so that we can do one thing if the key is there and another thing if it's not. If you go back to the notion of, did we see this person before? Yes, we did. Let's add a number. Oh, and then there's a new person. Now let's set that person to 1. So there's 2 things we're doing. If they exist, add 1. If they don't exist, make a new one and set their count to 1. So it's not just enough to make a new one, but we have to make a new one and set their count to 1. So what does that code look like? Well, it's conditional execution. It's an if statement. So eventually we'll read this data from a file, but here's some names, and we're going to go cruising through there. We'll start by making a dictionary. It's a dictionary of counts. Now again, I'm just calling it counts because it's a plural, because it helps you understand it. You don't have to name dictionaries with plural variables, although we commonly do it. We actually very commonly do that. So I'm going to have this for loop. The name is just going to go through as the iteration variable, and the if code is the intelligent part. So we're asking the question, if the name we're looking at is not in our dictionary, then set count subname equals 1. This is a variable, in this case of CSIV Chen, CSIV Jen. So that's getting things started. That's adding a new entry and setting it to 1. If, on the other hand, it's already in there, so we find Jen in this case, and Jen has like 2 currently. If it's in there, then we're going to run the else code, which means we're going to take this 2 out, we're going to add 1 to it, and then we're going to put it back in. So that's the idea of adding 1 or incrementing an entry in there. You pull it out, add 1 to it, and put it back in. So as this runs, it both makes new ones and then updates the existing ones. And like all loops, this is like histogram logic. When it's all said and done, we come out the bottom and we have a histogram. CSIV we've seen twice, Jen we've seen once, and Chen we've seen twice. So we end up with a histogram. So this is like the histogram logic. And again, just call your attention to this slide. Later you're going to be doing a lot of stuff. You might want to come back to this slide if you're confused by this is what it is. Because we're going to show you in a second a quicker way to do this. But this notion of if then else, if there's no key in the dictionary, put it in. If there is a key in the dictionary, do something to the existing value that's already there. That's something we're going to do so many times. And it turns out we do this so many times in Python that they have built something in that takes care of this for us. And the basic idea is there's going to be these 4 lines. We're going to do something if it's there. If not, we're going to set it to 0 or something. And so this get method, so counts is a dictionary, there's a get method. You can't use this on lists or strings, it's just part of dictionaries. So what counts.get is, it says go look up in counts, use this as the key, and this is the default. Meaning this is the value I get back if the key doesn't exist. So either it looks it up and it finds it, so CSIV, it finds a 2 and gives us a 2. If I looked up Bob here, it would give me back 0. The key thing it does is doesn't trace back, right? So this works whether the key exists or not, and you pick a default, okay? That's the get. That's the get. It's a method in dictionaries. Okay, so this is how we make a contraction. And this becomes kind of an idiom, meaning you can look at this and you need to understand it, but after the 10th time, you'll just be putting this line of code in and you say, oh, this is our little histogram trick. So if we look at it in slow motion, we're going through the names again, 3, 4 times, 5 times, and we're saying, okay, we're going to set the count of the name for that particular name, get the current count of the name or 0, and then add 1 to it. So if there is already a 4 in there, this becomes 4 plus 1 is 5. If there is nothing in there, we get 0 plus 1, and then we get a 1, and we store that in. And so if it is a brand new key, this is for new keys that are not there. And then existing keys that are already there, it pulls out, uses the get. And so this combines the if and the else in one line. So those 4 lines become one line. And so this does exactly the same thing as that thing with the if then else in that loop that we wrote in the previous slide with the if then else in it. So this is how we simplify counting. And again, this is an idiom. We're going to do this over and over and over again. Anytime we see a set of things and we want to build a count, we're just going to use this idiom over and over and over again. So now, up next, we're going to build this into a complete application where we really read through a file and we split the file. And this is the code that we looked at when we first started this class. So we're coming back finally, and we should now understand every single word.